Here's the introduction to rational functions. So in this lesson, I will not be going over specific graphing of functions, but just really the rules and more of the conceptual idea behind rational functions. So to start off, the form of rational functions is n over x divided by d of x, and really these two are just more than anything, they're just functions, right? They could be quadratic functions as shown here, or even linear functions. You could say specifically more like polynomials. So n of x is a polynomial, d of x is a polynomial, right? So those are rational functions. So if I have, and obviously d of x cannot be equal to 0, because if it is, then the overall answer will be undefined. Although that does lead into discontinuities and other stuff, which will bring in the concept of limits later. But looking at this, determine the domain of g of x is equal to this divided by this. Again, so domain is really all real numbers. However, we have to be careful to make sure that we are excluding all possible x values that are giving 0 in the denominator. And so really, if we think about this, x squared plus 9x plus 20, right? This is what we have here. And so if we want to factor this out, really this is x plus 5 times x plus 4, right? That's exactly what it is in the denominator. And so if we set this to 0, really we must set each individual factor to 0. Therefore x is equal to negative 5, x is equal to negative 4. Those are the two values for which the denominator will be 0 and therefore undefined. So therefore we will say that the domain in this case is really all real numbers except negative 5 and negative 4. So that's the idea here, and now we come to the idea of asymptotes. And with asymptotes, again, it's really something that our graph is approaching, right? It's there, it's tending towards, or it's approaching, but it actually never touches that point or that asymptote. It's just something that it's approaching, again, which brings into the concept of limits, what it approaches, right? And discontinuities. So looking at the vertical asymptote is obviously is vertical, right? So in that case, you're setting the denominator to 0, right? And what that means is essentially, since you have something here in the denominator, well, you factor everything off, and then you make sure that nothing in the numerator crosses off with any factor in the denominator. If it doesn't, if those factors in the denominator are distinct, then clearly you can set that factor to 0, and the value that you get there is the vertical asymptote, really. So you must set the denominator to 0, right, and solve as if it's like a quadratic function, if there's a quadratic function in the denominator. However, if there is a common factor, such as x minus a, common between n of x and d of x, then x is equal to a is a whole, and that's where the removable discontinuity comes in. So that's where that whole exists there. X is equal to a. In that case, you would not classify that as a vertical asymptote. So in the later video, I will be going over certain graphs, certain functions that have holes and have vertical asymptotes as well. Now comes in horizontal asymptotes. So these obviously have more rules here. Again, they're also asymptotes like vertical asymptotes, except the graph will be approaching these asymptotes in a similar manner, however, in a horizontal fashion. So if degree of n of x is less than the degree of d of x, right, then y is equal to 0 is the horizontal asymptote. So really, you see x squared over here, right? I'm just giving you an example here. Say it was something like, I don't know, if it was like x squared divided by x cubed or something like that, right? The degree in the denominator in that case would be 3, the degree in the numerator would be 2, and because the degree in the denominator is greater, right? Degree of dx is greater, then your horizontal asymptote is automatically y is equal to 0, which is really just, that's just the x-axis basically. So that would be your that would be your horizontal asymptote in that case. Now, if degrees are equal, right, in this case, this is that example where the degrees are equal, both are 2, both are 2 in that example, then your asymptote or your horizontal asymptote, that's y is equal to a over b, which really means it's the division of the leading coefficients, So in this case, the leading coefficient is 1, 1. So really, the horizontal asymptote in that case would be y is equal to 1. Now, if it was 5x cubed divided by 3x cubed, like say it was 5x cubed and then 3x cubed, really we would say that y is equal to 5 over 3, again, the division of the leading coefficients, is the horizontal asymptote. Now, if the degree of n of x, right, is greater than the degree of d of x, then no horizontal asymptote exists. Now, this implies that you could have something like x cubed in the numerator and then x squared in the denominator, for instance. In that case, no horizontal asymptote exists. Only a slant asymptote exists, which I'll go more in depth in the later lesson. And really, whenever you have a slant asymptote, in order to find it, it's really the quotient, really. And how do you determine it? Is you physically you end up dividing n of x by d of x, and you obviously can use long division or synthetic division, but again, synthetic division only works if you're dividing by something like x minus a or obviously it has to be a linear factor that you're dividing it by if you want to use synthetic division. Otherwise, you will be using long division. So that was just the introduction to rational functions. Thanks for watching.